Okay, here is an ALEKS problem talking about lattice energy, and so which compound has the bigger lattice energy. Really didn't need to do a video on this, but let's do it anyway, just to review the concept. So lattice energy, if you remember from lecture, has to deal with two things. One of them is charge. So ions and ionic compounds that have bigger charges typically have more lattice energy associated with them. So that's one thing that we need to keep in mind when trying to understand these problems. The second one is that the further down the periodic table you go, the lower or the less the lattice energy is. And so if there was a compound, let's just say lithium chloride versus sodium chloride, well, they both have the same equal number of charges, but because lithium chloride is higher in the periodic table, then just based on our rules for lattice energy, it's going to have a higher lattice energy. And if you remember from our lecture, that has to do with the proximity of the nuclei to each other in that ionic compound. Okay, so again, two things to keep in mind. Charge, the magnitude of the charge, the higher the charge of the ions, the greater the lattice energy, and position on periodic table, which has to do with the position of the ions and their nuclei to each other. Alright, so let's tackle this one. So rubidium sulfide and rubidium chloride. Well, rubidium, the sulfide ion has a -2 charge, and the rubidium has a +1. The rubidium +1 and a -1. So because the sulfide here has a -2 charge, whereas the chloride only has a -1, then this will have a greater lattice energy. We have strontium iodide and barium iodide. Well, the strontium and the barium both have a +2. The iodide has a -1, so let's go ahead and look at that periodic table. Strontium is here at 38, whereas barium is down here at 56. So the strontium in this case, since it's higher on the periodic table, will have the higher lattice energy. Alright, and the last one, beryllium chloride versus beryllium fluoride. Well, beryllium is common to both of those, so let's go ahead and look at the fluoride and the chloride. The fluoride is higher up on the periodic table, so that will have a higher lattice energy than will the chloride. So fluoride then will have the higher lattice energy. Let's make sure that ALEKS gives us the green, which we love to see, and it does. So lattice energy problems given by ALEKS are generally pretty easy to do.